Okay, let's look at example 2. Let's evaluate a radical expression. If you notice in this first example, we have the square root of b squared minus 4ac. And we're given the substitution for the variables a, b, and c. So we're going to substitute these variables with the numbers, and we're going to work the expression out using order of operations. And notice in this example, the radical symbol stays throughout the entire problem, kind of like if it was a whole group in parentheses. So let's go ahead down here and practice that. Here I have evaluate b squared minus 4ac for the given values. I have went ahead and typed in the values for you. And let's look at number 5. I'm going to replace b with 6, and it's 6 squared, minus 4 times negative 3 times c, negative 3. Now notice I keep everything underneath here, doing the order of operations all the way down to the very end until I get one number or one single digit, not necessarily one digit, a number, and then I can find the square root of that number. So the square root of 0, the answer is 0. Now if we look to the right, same deal. We've got the square root of b squared minus 4ac. So I've substituted in for b, minus 4 times a times c. Order of operations says to square, or do the exponent, the square first. 5 squared is 25. Minus this product, 16, which gives me 9. And see, I have a positive root here. This is my primary root. So I want my positive answer. The square root of 9, positive, would be 3. Okay, now let's go ahead and go to the back of this notes page. And let's talk about solving equations. This is going to put a little bit different directions than when we solve the expressions. If you remember when we did the expressions, we only had one answer, one root, one primary or one secondary root. When we're solving an equation that has an exponent and we want to get the x by itself, we're going to have to do the square root at the end. And let's look at this problem here. If I have 4x squared minus 22 equals x squared plus 5, and I want to isolate x and solve for x, I'm going to add 22 to each side of the equation, and then I'm going to subtract x squared on both sides. This gives me 3x squared on one side and 27 on the other. And you would show your work, divide by 3 on both sides. I have the x squared isolated by itself equal to 9. Now since it is an equation requires that you give both roots, both the primary and the secondary root. So equations, give both roots. The directions might not tell you to do that, but it's understood if it's an equation, you give me both roots. So the answer to this equation, x would be equal to 3, and x would also be equal to negative 3. Okay, so let's practice some of these. Here's another one for you to view. If you notice down at the end, they didn't put two separate answers like we did up here. They used the plus or minus 5, and that's perfectly fine too. Let's go ahead and do one of these. I'm going to go ahead and do number 7. Okay. So we want to get x by itself. So I'm going to isolate x, and I'm going to get rid of subtracting 54 by adding 54 to both sides of the equation. And that's going to give me 6x squared equals 54. Sorry about that. And then I'm going to divide by 6 on both sides. And that gives me x squared equals 9. And since it is an equation, I want both roots. So x is going to equal, well, what number do I square to get 9? I could have a positive 3 squared gives me 9, and a negative 3 times negative 3, or negative 3 squared, also gives me 9. So my answer is plus or minus 3. Okay, let's look at number 8. We'll do one more here. I want to get x squared, so I'm going to add 15 to both sides of the equation. And I'm going to get 5x squared equals 15. And I'm going to undo multiplication of 5 by dividing. And I have x squared equals 3. Well, I need to solve for x. And again, since it is an equation, I'm going to have two roots. Well, if you undo x squared, you have to square root it. And whatever I do on one side, I must do on the other. Now the square root undoes the square. And I know I didn't show it in the previous problem, and I probably should have. So the square root of the square, that undoes each other, so that just gives me x. But is there a number that I can square, a positive and a negative number, to get 3? Well, not a whole number, no. So my answer is in simplest form. But remember, I have to have two roots. So my answer is plus or minus square roots of 3.